Hi everyone, this video is part of Macquarie University's coding tutorials, and today we'll look at implementing a recursive design from the previous video. Once we've implemented our solution, we'll use a debugger to run the program and check its state, seeing how the formal parameter values are different in each stack frame. This will help us to better understand the mechanics of recursion and how it works in practice. In the previous video, we identified the base case and recursive case for the shopping on a budget problem, and then created the recursive algorithm to solve it. We identified the base case as the simplest form of the problem that we can solve, which is when we run out of items to buy or run out of money to spend. When we reach the base case, we simply return the amount of money we have left. We then identified the recursive case as being when we still have items to buy and still have enough money left in our budget to buy the current item. To solve the recursive case, we pretended that we made a clone of ourselves and gave that clone a new budget. This new budget has the cost of the item we just bought removed, and the clone is then asked to ignore our item and start at the next one. If the clone is able to buy their item, they will then ask another clone to do the same with a new budget and the next item, and so on. This process continues until we hit the base case and all items are bought or we have run out of budget. With this in mind, let's move on to implementing the recursive solution in code. We'll start by creating a new Java project in Eclipse and naming it Shopping on a Budget. Then we'll create a new Java class and call it Shopping. In this class, we'll create both the recursive method and the main method. To make the code writing process easier, I've transformed the design that we made into step-by-step comments. This is a very important step that will not only help you to write code, but will also help to document what is going on in the code. Feel free to pause the video here and look through these comments. Type them into your own class so you can follow along, making sure you understand how these comments relate back to the design that we made. Now let's start by writing our main method. Here we'll simulate a shopping trip by creating an array of prices for the items and setting a budget for the trip. We can create a double array and call it shopping list, adding in sample values like 10, 70, 20, 90, 30, and 80. Then let's create a double variable called budget and make the budget a figure like 150. Let's leave the third comment for now until we've created the recursive method. To begin, let's define the method signature. As we are returning the leftover budget at the end of the trip, the return type should be double. We'll call the method leftover budget, which will take three parameters: a double array shopping list, a double budget, and an int current item index. Shopping list will have the prices of the items we can purchase, budget will represent how much money we currently have, and current item index will be used to tell us the index of the item we are currently considering buying. Now let's implement the base cases. In the base cases, we want to check whether we have run out of items to buy or if our budget isn't enough to buy the current item. To check if there are no more items left, we can see if our current item index value is greater or equal to the length of the shopping list array. Then to check if our budget is not enough to buy the current item, we need to compare the budget to the item's price, checking to see if the price is greater than our budget. We can get the price of the current item by indexing into the array with the current item index, which we know will be a valid index when our first base case isn't true. In both of these cases, we'll return whatever the budget is, as there are no more purchases to be made. Now for the recursive case, we'll simulate the purchasing of items one by one. We'll update the budget, print the item's cost, and increase the current item index with each purchase. At this point, we are guaranteed that there are items left to purchase and our budget is sufficient to purchase the current item. First, we'll subtract the price of the current item from our budget as we'll have spent it. Then, we'll print out the price of the item as a visual aid for the purchase. Before making the recursive call, we'll increment current item index. This is our way of telling our clone to check and look at the next item instead of the item we just purchased. Now we'll call the function recursively with the updated budget and current item index, essentially passing on the work of checking the next item to a new clone. Now let's finish the main method by calling our recursive method and passing in our shopping list, our budget, and a starting index of 0. We'll store the return value into a variable called leftover, which we'll print to see how much we are left with. Now if we run the code, we see that we have purchased the first 3 items and their costs printed to the console. The sum of these costs is $100, leaving us with $50 of our budget, which is not enough to cover the $90 cost of the 4th item. Now that we have our recursive method implemented, and it is being called in the main method, let's use the debugger to step through the program and see how it changes as we go through different stack frames of the same method. To start, let's set a breakpoint at line 10 of the main method where the leftover budget method is called. We do this by double-clicking in the left-hand margin of line 10 where a blue dot appears. Next, let's run our program in debug mode. You can do this by clicking on the green bug icon besides the run button in the toolbar. Alternatively, you can right-click on the file containing our main method and select Debug as Java Application. Both of these options will switch Eclipse to its debugger perspective. The debugger will stop at our breakpoint and we can now step through the program one line at a time. To do this, we can use the step buttons in the toolbar. Click the Step Into button to step into the leftover budget method. The method call is added onto the stack and we are now inside the leftover budget method. We can see the values of the parameters in the local variables panel. Notice that currently the parameter values are the same as our original method call in the main method. That is, we have a budget of 150 and we're starting at index 0. Click the Step Over button to execute the if statement on line 20. Since there are still items left, this condition is false, so we skip the line 23. Click on the Step Over button again and we'll skip the line 30 as we have sufficient budget to buy the current item. Stepping again, and we'll see our budget has changed to 140 in the variables panel as we have just subtracted 10 from it. Here, as we are calling the print method and we aren't interested in how this works, we'll use the Step Over button to skip over the code it uses to print. Clicking Step again, we increment the current item index, which we can also see in the variables panel. This puts us at line 39 where we call leftover budget. Notice that this time we are passing in our new budget and current item index values as parameters. Here we'll click Step Into as we want to step through the code in this method, and you'll see that a new stack frame has been added with the previous not yet resolved. Feel free to pause this video and continue repeating this process of stepping through your code. Note that how each of the added stack frames are for the same method but are different method calls. Each stack frame will have its own parameter values updated by the previous stack frame, which we can see in the variables panel. Eventually, the method will reach one of its base cases and return the budget back down the call stack, resolving each of the method calls along the way, eventually returning to the main method. You can continue to step through the rest of the main method, or once you feel satisfied with your debug tracing, you can click on the Resume button to let the rest of the program run normally, as there are no other breakpoints. And that's it. Using the debugger is a great way to trace through your programs and see how they work, especially when dealing with complex recursive methods. By stepping through the program one line at a time and checking the values of our variables, we gain a better understanding of how recursion works. In this video, we implemented the recursive solution to the shopping on a budget problem, which we designed in the previous video. We also use the debugger to trace through the recursive method calls, observing the formal parameter values. It's important to remember that designing our solution before writing the code helps us break down complex problems. In the next video, we'll take a look at how we can transform an iterative solution that uses loops into a recursive one. See you there!